Okay, back in the late 19th century, there was a scientist by the name of Arrhenius, and he was a natural scientist like Darwin. But one of the things that Arrhenius did was he did the back of the envelope calculation for how much, if you added more greenhouse gases, CO2 in particular, to the atmosphere, how much would the Earth warm? And we talk about this in terms of climate sensitivity. And because it's not a linear process, we talk about how much doubling of CO2 would raise the temperature of the planet. So you'll hear climate scientists talk about doubling CO2 from what it was before, pre-industrial, before we started pumping all this greenhouse gas into the atmosphere. So that was about 280 parts per million in the atmosphere. If you double that, it's 560. So the climate sensitivity is how much warming does that represent? So actually for a long time now, it's all sort of been around 3 degrees. So how do we get there? Well, it's basic physics and the kind of experiments that people like Arrhenius did, and actually what I did in first year physics, was you can actually look at a light source with a package of atmosphere in it, which you can change the chemistry of. And if you shine a light through one package of atmosphere that, let's say, is 280 parts per million CO2 versus 560, you can see how much more of the short radiation, the infrared radiation, gets absorbed by the CO2 molecule. So this is the basis for the atmospheric circulation models, the real physics. There is real physics in these models. They aren't just models that people just make up out of nothing. They're actually based on real data, which you can generate in the lab. And that basic data is how much energy is absorbed by a certain amount of CO2.